Hi, I'm Felipe Bravo Marquez, main developer of the AffectiveTweets package. I work in the Department of Computer Science of the University of Chile and also hold a research associate position with the Department of Computer Science of the University of Waikato, New Zealand, the home of Weka, a toolkit for doing machine learning. AffectiveTweets is a software for analyzing emotion and sentiment of tweets. And in this demo, I will show you how to use the package. So I hope you have read already all the information in the website about how to install the package. In this tutorial, we will assume that the software is already installed. So I'm going to go to Weka. This is the Weka software. And you should check first in your package manager, that's what you have to use to install extensions for Weka, that AffectiveTweets, our package, and LibLinear are already installed. So in our case, we can check that AffectiveTweets is already installed and LibLinear as well, which is a software for training linear models such as logistic regressions and support vector machines. Okay, in this tutorial, I will show you examples that are very similar to the ones that are already provided on the website. But I will show you how to create these models in an interactive way. So our goal here is to train classifiers for sentiment of tweets in a very graphical way. So I will click now on the Weka Explorer. And this is the interface of Weka that allows us to open datasets, transform the datasets into different formats, and also train classifiers using many different machine learning algorithms implemented in Weka. So the first thing I'm going to do is to open a dataset, and luckily AffectiveTweets comes with some datasets. So those ones are located in the home folder in your home directory in a folder called Weka files. So there is a folder called packages. Now we go to AffectiveTweets and data. And most of the datasets come in compressed format. So the dataset we are going to use in this tutorial is this one, send140test.arf.gz. This is a very small dataset and serves more for a tutorial. It's not a very real big dataset. Anyway, it has three attributes: content, which is the tweet itself; topic, which is the topic discussed in the content; and the class, which is the sentiment. This is a human provided label. And we have three possible labels: negative, neutral, and positive. If we click on edit, we can take a look at the tweets we have. The topic, which is not going to be relevant for our experiments, and the class. So we have here a negative tweet, here we have a positive tweet, and so on. So in AffectiveTweets, we have many new filters that are not originally provided by Weka that allow us to extract attributes from tweets that are useful for sentiment. For example, we have the tweet. Most of them start with the word tweet. We have, for example, the tweet to sparse future vector. This one extract features, very sparse high-dimensional features such as word engrams, character engrams, and so on. With the default configuration, we first need to select the text, the attribute on which the attributes will be extracted. So in our case, it's the content. So we have other options, there are many options, and the description of them can be obtained by clicking on more. Okay, so by default, we are only going to extract a word engrams of dimension of 1. Okay, so I'm going to click on, and we can also do things like lowercase a tweet. We can reduce repeated letters, like when we have, for instance, a word like love with many O's, we can replace them to just 2 occurrences of that letter. We can also standardize URLs and user mentions to unique attributes. This will allow us to reduce the attribute space and so on. There are many things that can be done here. Okay, so I'm just going to click on this filter. I will apply it. And now we have many more filters based on the words that occur in those tweets. But we have more filters. A very popular thing to do for sentiment is to extract filters from lexicons. What are lexicons? They are just lists of words annotated by sentiment or emotions. So in our package, we have this tweet to lexicon filter vector. Tweet to lexicon filter vector allows extracting filters using many well-known existing lexical resources that have been created by various researchers across the world. If we click on more, we can get definitions about those resources. Basically, what we are going to do is for each tweet, count how many positive words we have, negative words we have, according to each lexicon we are using. Sometimes those lexicons also provide the sentiment scores that are numerical values. In those cases, what the filter is going to do is going to sum all those scores for the words found in the tweet that match the given lexicons. Okay, so by default, many lexicons are used, but they also can be set to false if we don't want to use them. So by default, we're using all of them. Okay. An appealing attribute of Weka is every time we set up, configure a model, we also get a configuration string. This also can be used for when using the Weka graphic interface, the Weka command line interface. In those cases, we can just use the same configurations. A very appealing feature of Weka is that we can copy this configuration to the clipboard and keep it for later. For example, and that's because I'm using Notepad here to keep track of those configurations that can be useful in the future. Okay, so let's extract features from using the lexicon. And now we see that we will have many more new attributes. Okay. Senti-WordNet, Senti-emoticons, and NRC, trust. So we have now features about many different things, about emotion, sentiment, and calculated from different lexicons created by different people using different techniques. So let's try now to train a classifier that uses all this information as features. So I'm going to get rid of the content and the topic that are not useful now. Our classifiers will deal with numeric attributes. So I'm going to remove those things. And I will train a classifier by going to the classify panel. So let's use a very fast support vector machine from the liblinear package. So let's define our target class, which is nominal, as the class sentiment, and use liblinear. By default, we are going to use a support vector machine. Okay. And let's use just a percentage split because it's going to be faster than running tenfold cross-validation. So let's do it. This is a very fast thing, and we obtained some results that are quite good. So we obtained 78% of accuracy and an weighted average F measure of 0.78, which is quite good for sentiment classification. Okay. So now what I want to do is to show you how to train a classification model in one single pass so that we don't need to use the preprocess panel and the filters are nested as part of the classifier. This is going to be very important when we want to, for instance, serialize our classifier into a file that we can deploy on new unlabeled tweets that we want to classify. And it's also very important when we have features like the word engram features, in which we want the features from the training set and the testing set to be compatible with each other. So that means that we want to extract the dictionary of words just from the first batch, only from the training set. A very nice way to do that in Weka is using a meta filter called the filter classifier. So the filter classifier receives one classifier, like an SVM, and also a filter in which we can apply all the transformations we did previously in the preprocessed panel. So the question is, how can we nest many filters next to each other using Weka? For this, we have a very special filter called the multi-filter. So in this filter, we can put one filter next to each other. For example, we can have n-gram filters, lexicon filters, word embedding filters, and so on. Okay, this is what I'm going to show now. So as a classifier now will run the filter as part of the classifier, we need to start here with the raw data. So I'm going to click on undo until recovering the original data. Okay, as this is going to be my plan now is to try with a very complex classifier that use filters from many different AffectiveTweets filters. So what I'm going to do first is to set up the whole filter using the multi-filter, and then I'm going to copy that configuration to the clipboard so we can keep it, and then we're going to paste it back to the classify panel as the filter of the filter classifier. Okay, so let's play around now in the preprocessed panel and try to use the multi-filter to use many different AffectiveTweets filters. Okay, so let's go to the multi-filter and let's try with various filters. Those ones come in here. Okay, so let's try for an unsupervised attribute level attributes. We're going to use the tweet to lexicon filter vector, the same one we used before. We're going to reduce repeated letters, standardized URLs. We're going to do the same with all our filters, and we're going to use all the different lexicons. Okay, this is going to be the first one. And of course, we have to make sure that this text index attribute corresponds to the attribute containing the tweets, because this is the content from which those attributes are going to be calculated. Okay, what else? Let's play around with something called tweet to input lexicon filter vector. The main difference of this filter and the previous one is that here we can extract filters from lexicons provided by the user. For example, if you have your own lexicon that is not included in the previous filter, you can use it here. So what do you need? You need the lexicon to be in R format, which is the standard format for Weka. Okay, and we click here on R lexicon evaluator, and we are going to select the lexicon we're going to use. By default, and this is going to be a file. By default, Weka come with some lexicons, and we're going to use the NRC affect intensity lexicon. Okay, we set this one and we add it. So we have now, now we have only one lexicon here. This is done, and now we have add here. No, I'm making a mistake here, sorry. What I'm trying to do here is we have the tweet to lexicon filter vector and also the tweet input lexicon filter vector. Okay. So we are also going to use senti-strength. Senti-strength is an existing method for calculating sentiment intensity scores for sentences, usually social media sentences. So we'll calculate a positive and a negative sentiment score. And this is going to be done using an existing lexicon and rules for normalization, working with intensifiers and negation. Okay, so we have another filter here. Sorry, we have now 3 filters, and we're also going to use word embeddings. Word embeddings are vectors of words that are pre-calculated. It's a very popular technique for obtaining representations for words. Word embeddings are just vectors for words that represent semantics. So here, so usually they're pre-calculated using algorithms like word2vec or globe. So here we need to select which is going to be the file containing those word embeddings and the action. So how we're going to use these word vectors that come in a list of in a particular file to create tweet level filters. In our case, the action means that we are going to average those word vectors. Okay, so we need to set up the embedding handler, and by default is coming with a CSV, so assumes that the embedding file comes in CSV format, and the separator is a tab character, and comes AffectiveTweets come with a very small word embedding file that can be used. Also, this can be changed to embeddings trained with from larger corpora. Okay, but we are going to use this one for this demo. Okay, so we have now 4 filters, one next to each other. And if we click here on apply, now we're going to run all those filters on our data. So it's taking a while. But this is what we got. Excellent. We have embedding features, we have scores from Centistrength, and all scores from this input lexicon we provided, the NRC affect intensity lexicon, and also attributes from all the different lexicons. And we can play longer. We could add also n-gram features if you want, and try and explore many different combinations of features. So what I want now is to obtain one configuration that will transform the data in a way that is ready to be classified by any classifier using the filter classifier in the classify panel. So what I'm going to do now is to add another filter that will reorder the attributes and will discard the topic and the content that are not relevant for our classification goal, and we'll leave the classification, the class as the last attribute. How we're going to do this? Using another filter that comes with Weka called reorder. This is reorder. So we are going to put reorder as the last filter, and we need to define what is going to be the new order of attributes. So we want to start with this one, mpqa post count, which is the 4th attribute. Until the last one. And then we want to put the, sorry, I made a mistake here. And then we're going to put the class attribute at the end. And this one, if we undo this and we run this thing, will hopefully transform the data set into the shape you want. So only the attributes first and just the class in the end. Okay. Lovely, this is what we wanted. Okay, so what I'm going to do now is to nest this classifier this filter, this multi-filter, into the filter classifier so we can do classification and filtering in one single pass. So I'm going to copy this configuration to the clipboard. And sorry, I'm not very familiar with Windows. I'm a Linux user, but this should go well. Okay, this is what we got. This is the whole configuration of all these attributes. And this is exactly the things that are shown, the kind of things that are shown here. Okay, this is exactly the kind of things that are shown here, that I know can be a little bit cryptic, but with this example, I'm showing you how you can obtain these things. The neat thing is that then you can use these configurations, you can paste them into the command line interface and train a classifier, for example, or a filter using a bash script. Okay, So let's go again to the Web Explorer. Let's undo things, go back to the original dataset, and now let's try to use the filter classifier. So here, as the filter, we're going to paste all the filter we got here. So we're using lexicon, input lexicon, sentence strength, and embeddings. Then we are reordering the attributes. And we are going to use, again, a support vector machine. Okay, let's see if this new model is better than the previous one. So now Weka is extracting all the attributes, and after extracting all of them, it's training a model. Took 17 seconds to build the model. And we should obtain classification performance very soon. That's what we got. So now we got an F measure, weighted average F measure of 0.77, which is worse than the previous one. How? Okay. So that shows us that for this small data set, adding additional features wasn't very useful. Okay, I hope you like this video and you can now have a better understanding of how to use AffectiveTweets. Good luck. See you soon.